All right, in chapter 2, section 2, we're going to be looking at more on functions and their graphs. There are a lot of different topics in this section, so I'm going to kind of chunk them. The first video is going to be over increasing and decreasing intervals, and then also on the back on the next page. Okay, we're also going to talk about relative maximum and relative minimum. So in this video, that's going to be the focus. And then in the next video, we'll pick up from here on down, from symmetry, and then whatever's left in this section. Right, so we're looking at more on functions and their graphs. So the idea here is increasing, decreasing intervals. So the x intervals over which the function values, that's important too, increase or decrease. And a reminder that function values is just a phrase that represents the y values. So we're going to be looking at graphs, and we're going to try and determine where on what intervals of x that graph is going up or going down. And it's very intuitive. I think if you look at this graph right here that's presented as an example, we can see that when we jump on the graph, and we always read from left to right, when we jump on this graph, I have to travel down. So this graph is decreasing here, but then at this turning point starts to increase. At this turning point, the graph decreases. At this turning point, the graph starts to increase until infinity. So I'm thinking that increasing, decreasing is kind of intuitive. You can look at a graph and kind of see where on the graph that behavior is occurring. What's not so intuitive is maybe the notation that represents whether a function is going up or whether a function's going down, increasing or decreasing. So I'll try and keep this notation to a minimum, but I still think it's pretty important that we look at it. Okay, so it says for a function that's going up or increasing, it says for any x subscript 1 that's less than x subscript 2. This is just notation that keeps track of two x values on an x-axis. So I don't know that I would write this in, but if you want to, that's fine, but I'm just going to kind of show what this notation means and why it has to be this way for us to have an increasing interval. For any x subscript 1 that's less than another x subscript 2. So I'm just going to come down here and say, well, what if we call this x subscript 1? I don't know what that x value is, but it's located right here. And ignore the graph that's on here. I just want to use this grid. And then let's say that I have x subscript 2 right here to the right of x subscript 1. Because x subscript 1 is less than or to the left of x subscript 2 as indicated by this notation. For a function to be going up, then it has to be true that this y value at x sub 1 is less than this y value at x sub 2. Meaning, let's go back to x subscript 1. I'm just going to choose a point. I'm going to just travel up, and I'm going to say, okay, I'll stop right here. So this ordered pair would be x subscript 1, comma, f evaluated at x subscript 1. Another way to say the y when when the subscript is x sub 1. So as long as I have a function that's increasing, as long as this y value is underneath or lower than the y value that occurs when x subscript 2 is my new x. So I'd have to put a y value up here in order to satisfy this requirement that this y is less than this y. This y is lower than this y. And if you think about connecting these 2 points right here, then you can really see that the graph of that function, whatever it would be increasing. That's just what that notation means right there. Well, likewise, what about the notation that represents a decreasing function? Okay, well, let's interpret it. It says for any x subscript 1 less than x subscript 2. I got them right here. Now it must be that this y value is greater than the y value occurring at x subscript 2. Which means for that situation, this y value that I choose to put right here has to be a higher y value than the y value I put at x subscript 2 in order to satisfy this requirement. And we can see that when we read from left to right that this y value is greater than this y value right here. So if you connected these 2 points, then that graph between them would be decreasing. So don't want to get caught up in this notation too much because like I said, increasing and decreasing is rather intuitive. All right. So graphically, if the function is increasing, we also say that the slope of that graph is positive. So anytime you can see a section of a graph that's increasing, we would then also say, well, the slope of that graph has to be a positive number. The y's are going up, that makes sense. If the function is decreasing, then the slope of the graph is negative. Well, that makes sense. Your y values are decreasing, so the slope between those 2 points should be a negative number. All right, so the takeaway for what we're going to be doing, because we have an example here that's already done for us, but we'll kind of look at it and deconstruct it, and then we have our own example right here. Here's the important takeaway for increasing and decreasing intervals. The intervals are written in terms of x values, and we're going to use interval notation to describe a set of x values where a graph is either going up, increasing, or going down, decreasing. So we're going to use interval notation. So intervals are written in terms of the x values, and we always use open intervals. So let's remind ourselves what that means. That means that we won't use any brackets, only parentheses. So if we're asked a question to describe where a function is increasing or decreasing, we cannot use brackets. And we never include the x value of a turning point. So what does all that mean? Well, let's come down here and look at this example. It says, reading from left to right, this graph is falling or decreasing as shown. Yeah, I see. Okay, and it continues to decrease until we get to this turning point right here. Right here, the graph changes from decreasing to increasing. And the question is, where on the x-axis does this happen? And so if you were just think about pulling this point up to the x-axis so you could read off the x-axis, what is the x-coordinate of this point? Well, it's -1. So this graph right here is decreasing from negative infinity, because it comes on way up here. So negative infinity, it decreases on the x values from negative infinity up until we get to an x value of -1. So I'm going to try and color code this. So we're decreasing here to x equals -1. I never even mentioned the y value because intervals are written in terms of x values. I can clearly see that the y values are decreasing, but on what x interval is that occurring? So if we come over here to decreasing, we can see that the first set of x values are described by interval notation from negative infinity up to -1. The graph starts to increase and then it begins to decrease again. So if I highlighted that part of the graph that's decreasing, I would highlight this region right here. So where on what values of x is the graph again decreasing? Well, we can see right here at x equals 0, at this turning point, the graph starts to decrease, and then it stops decreasing right here at this x value. Well, what is this x value? I don't even care about the y values. Well, the x value is read from the x-axis. If you bring this point up to the x-axis, you can see that x equals 1 is where this graph stops decreasing. So on the interval of x equals 0 up to x equals 1, my graph is again decreasing. Again, remember that this set of parentheses right here does not represent a point on the graph. In the context of what we're doing, this is interval notation, which describes a whole bunch of values in between 0 and 1, but not including 0 and 1 because we have the parentheses, not the brackets. Well, let's do the same thing for increasing. So first thing I'm going to do is I'm going to highlight those parts of the graph where I feel like the graph's going up. Well, right here and then right here. So what are the intervals of x on which these parts of the graph are increasing? Well, go to the furthest left part of this highlighted pink region. What's that x coordinate? Well, that x coordinate is read from the x-axis. It's -1. I will increase until I get to x equals 0. So using interval notation, I would say that the graph of this function is increasing from x equals -1 to x equals 0. Then I also have to describe the interval of x's on which the graph again increases. So where does the graph, on what value of x, does the graph start to increase again? Well, at this x value, which read from the graph, is 1, and the graph continues and never stops increasing. So we say that the graph is increasing up to positive infinity. This graph right here doesn't have any flat spots on it, horizontal spots. So this graph is never constant. It's either increasing or decreasing. All right, let's try one of our own. Feel free to stop the video and try this one on your own and come back and see how you did with your intervals that describe, your x intervals that describe where the graph is increasing, decreasing, and constant. So I'm going to start from left to right, and I'm going to highlight the decreasing parts of the graph. Graph decreases, increases, constant, increases, decreases, increases, and constant. So now I'm going to highlight where the graph is increasing. Increasing, increasing, and increasing. And we have a new idea here. We have the constant parts of this graph, which are here where they're flat or horizontal. The slope is 0, by the way, when the graph is constant. Remember, the slope is negative here and here. The slope of the graph is positive here and here and here. And we have 0 slope. There's no rate of change. The y's are staying the same. Okay, things to take away whenever you're describing increasing and decreasing intervals. Never bracket, only parentheses, and you're using the x values where that behavior's occurring, where the y's are increasing, decreasing, or staying the same. I might just work my way from left to right. So from negative infinity way over here, because the graph does extend from negative infinity up until I get to this turning point right here, my graph is decreasing. I can see that. So I'm going to find the decreasing, and I'm going to say from negative infinity up to the x coordinate, and I'm going to have to bring that x coordinate up to the x-axis so that I can come back to the origin and count over. 1, 2, 3, 4, 5. So my graph is decreasing from negative infinity up until negative 5, and it has other behavior. And we could use the union symbol, or we could use a comma, just to represent that we have different sets combined here. So I'll just do a comma. It means the same thing, comma or union. I can't remember what's used on my math lab, but it might even be a union symbol, which is this little U like this. Okay, the next interval of x values where the graph of this function is decreasing would be from this x coordinate to this x coordinate, from this turning point to this turning point. So what is this x coordinate and what is this x coordinate? Well, on this interval between x equals 1 and x equals 4, okay, if I said, let's look at the x values between x equals 1 and x equals 4, that part of the graph is decreasing. So we just found our other decreasing interval. All right, I'm going to go now and look at this next section where it's increasing, and then I'm going to name that interval of x's and name all the other sections of the graph where the graph is also increasing. All right, so the increasing interval that I want here is from this x down here to this x up here, and if I read those x's from the x-axis, this is -5 and this is -3. So on the x values from x equals -5 to x equals -3, I can clearly see that the y values are increasing. I don't care what the y values are for this question. I want to name the x's where this behavior is occurring. So -5 to -3. Remember, never brackets, only parentheses. All right, let's look at this next pink section where my function's increasing. What are the x values on which this function's increasing? Well, this x value is -1, and this x value at this turning point at the top here is +1. So I'm going to union that with the x values between -1 and 1. Remember, this is not a location, a point on the graph. This describes the x on where the graph is increasing. And it looks like I have another pink section, so let me do another union. You can do as many as you want. So from x equals 4 to this x value right here, just on that small little section of x's, the graph of the function is again increasing. So this must be 5. So union 4 to 5. All right, and then we also want to consider intervals on which this function remains constant, intervals of x's. And we could see that that's going to happen here from x equals -3 to x equals -1. and then again from x equals 5, and it never stops being constant, so we go 5 to infinity. Those are the x's on which the function remains flat. If we went back and we combined all these sets together, if we started from negative infinity and went to -5, and then went from -5 to -3, -3 to -1, we would see that every x value from negative infinity to positive infinity is represented in one of these sets of x values here. It's clear that the domain here is all real numbers, because as you move across from left to right, there's no breaks or gaps in this graph. So if I were to combine all these sets of x values, I should get a representation of all real numbers from negative infinity to positive infinity. All right, that's increasing and decreasing. One more topic in this video, and we're going to talk about on the next page, we're going to talk about relative maximum and relative minimum. So if you want, just kind of pause the video and read through this language, these terms, and these definitions. All right, a relative maximum, a relative minimum. Okay, these are points, ordered pairs, xy coordinates that fit between parentheses. So now we're kind of switching over from parentheses being used to describe a bunch of numbers in between something to where an ordered pair or parentheses represents a location, one specific location on a graph. So relative mins and maxes are going to be represented by the points where the function changes from increasing to decreasing or vice versa. I've already mentioned the turning points. So intuitively, I hope we can think that a relative maximum is the highest point in a specific region on a graph. And a relative minimum is a low y value in a specific region on a graph. And these two words, relative and local, they mean the same thing. Sometimes they're called local maximums and sometimes they're called relative maximums, but these two mean the same thing. Okay, so and notice how we're going to report a relative maximum or a relative minimum. We're not going to use an x coordinate, we have to use the y coordinate, because that describes the highest y and the lowest y. We wouldn't want to use the x to talk about the highest and lowest points, we'd want to use a y. And we write that as an ordered pair. So let's look at our graph here of this function. Passes the vertical line test, so it is a function. The domain is all real numbers, just revisiting some things. The domain is all real numbers, as is the range. The range is also all real numbers. Okay, we're asked to find the relative maximum. Okay, so I'm looking at this graph and I'm going, well, I know this graph continues way up, so the maximum probably is going to be way, way up here. As a matter of fact, it doesn't ever have an absolute maximum because the graph continues going upward. But we look for peaks and valleys, highs and lows in a select region. So let's just kind of focus our attention maybe on this selection of the graph. So right here, I have a relatively speaking, I have a maximum that it's occurring in this neighborhood right here. So what is the ordered pair that represents that relative maximum? Well, let's read it from the grid. Here's the turning point, left 1, up 2. So the relative maximum for this graph is the ordered pair -1, 2. I'm not talking about everything in between. I'm talking about that specific location. That gets kind of weird when you use interval notation because you have to kind of be aware, how am I using parentheses? Is it, a point? Or is it like a collection of x values? And it's the context that we're working on that determines, what that situation is. And what's the relative minimum? Well, in a neighborhood, I can see that's kind of a turning point. That's a low spot. So if I just focus my attention right here in this area, I could say that that ordered pair of that turning point, 1, -2, would be our relative minimum. I'm not sure if my MATLAB asks for the ordered pair. Sometimes they ask for, the way it's worded is, it says the number at which f has a relative maximum. And the number at which it does have a relative maximum would refer to the x coordinate. Now, if it asks you what is the relative maximum, then you'd want to use the y coordinate. So really pay attention to how the question's being worded, because sometimes they want not the ordered pair, sometimes they want the location indicating the x coordinate, and and sometimes they want the actual value, value meaning y, they want the y value. So it's just real important to kind of pay attention to the language. Yeah, I think you get 3 attempts at it anyway. If you miss it the first time, try the other. All right, that's going to wrap up increasing, decreasing intervals and relative maximum, and relative minimum.